Some dear people, if you're watching this video, you might have seen already the first episode of the Aegis project, and you might be wondering, well, what are we doing today? Well, essentially we're not doing much today. We're actually going over why I just shelved the project one episode after doing it. Okay, so for context, the Aegis project is a project whose goal is to try to use genetic algorithms for the sake of trading strategy generation. Well, the issue is that while I had a basic idea of what I wanted, and it was supposed to be, let's say, the next step of a project that I had already started, was focusing on portfolio optimization, I didn't have everything figured out as I started it, okay? Which meant that a lot of the decisions that I made were driven on one side by the research that I had already done, which was admittedly pretty shallow, and on the other hand, by just conversation with AI to see what I could do, etc., etc. Okay, and that shows you already one of the pitfalls of AI-driven development is that if you don't really know what you're going for perfectly yet, it is really easy to get led astray. And the first issue that, we encountered is that after reviewing, because, I have 300,000 tokens of code to review, and before going to review that, I figured it would make sense to just pass it by an AI and have it analyze it and tell me, what is already there, what is actually there, and if it's even worth the hassle. Doing that kind of aligned with my intuition that, it wasn't. And while some of the points that I mentioned here were things that I actually thought were good things at first, for example, the AST abstract syntax tree to interpreter approach that I had chosen, because at the time when I was doing it, the goal was to ensure complete safety. The AI had actually mentioned the idea of using bytecode in my last discussion, but because I hadn't quite understood it, and it seemed I was working with the risk on one side of having a program generating unsafe code and then having to run it, and I wasn't really too sure what would be the right way to contain that in a way that wouldn't destroy my machine, versus going for the slower but guaranteed safe option of just using ASTs. I had opted for ASTs at the time. The thing I hadn't kept in mind is that I'm working with Rust, which means, I imagine with most languages you could do something quite similar, but the idea is that Rust type system allows you to write a CPU and a lot of those low-level constructs really intuitively, and as long as I make sure that the VM, the virtual machine implementation that I have, actively catches those malicious code generations, and actually, if I just don't give the program the opcodes necessary to write that kind of malicious code, it was unlikely that I would even run into that issue in the first place. So I was running into losing performance on one side by using AST to have something that is perfectly safe, even though the simpler approach and arguably better approach, because I have a direct conversion to whatever language I want next, is to just use a stack approach with bytecodes and then transform those bytecodes, transpile them into whatever language I'd wanted. So that's the first reason why I dropped this thing. The second thing is that, that doesn't really require a full drop of the project. But that is one other thing that came up while I was reviewing, which is the fact that the way I had done the grammar was, while I'd done it with good intentions, and yet again, my logic was that from the little research I had done, a good robust strategy should have an entry, an exit, a take profit, and a stop loss. And so I had the idea that the grammar should enforce the fact that every strategy should have an entry, an exit, a take profit, and a stop loss. The thing is, while well-intentioned, this was also misguided because, one of the most efficient strategies of all time is just buy and hold, which is, you buy, you have an entry based on some condition, and then you just never leave. So you don't really care about take profits, you don't really care about stop losses at this point. You just buy and then hold till the end of time, until it's time to cash out because you need a cash for whatever reason. This was fundamentally unrepresentable by my grammar, which is kind of silly. And the fact that I say it that way shows you that like there's many other things that, well, you might imagine that a grammar, like an agent, that's something evolving strategies, might be able to figure out that maybe based on some entry condition, I don't need an actual full exit condition to go with it. I might just want a stop loss or like some kind of take profit to every time we reach a new stage, let's say, to take some of my investment away and then wait until the next time to like let that pile of cash keep growing, okay? Like all of those things that I'm talking about here were things that were fundamentally unrepresentable by my grammar. And while this is something with the grammar itself, since the code for the mapper was tightly coupled with whatever vision the AI had in mind, and so instead of going through the hassle of modifying code that AI wrote in the first place, I figured I might as well just make a better version by starting from scratch. And the new approach that I chose was to use the grammar itself, and I can pull that up, okay? So it does something really similar, except that optional non-terminal here for everything that is, let's say, nullable. So optional exit here, in the future we'd have optional take profit and optional stop loss as well. Each time, if we look here, we see that the optional exit can be replaced by nothing, so just remove it entirely, and exit program. So like we actually evolve an exit program. And when we evolve an exit program, we have a non-terminal entry with a Boolean expression that tells us when we actually, what exactly is the entry. So these here become the name of those programs, okay? And then we are able to have the map tester run the strategies, and intelligently, when we are in a position, it knows that, okay, we might want to call the exit program the take profit or the stop loss. When we're not in a position, we would want, the only thing that makes sense to call is the entry program. And so intelligently, based on the context in which we are, we would check the programs that we have available, and those programs would be stored in a hash map. And then we would check the conditions that apply to then use that as the action call, let's say. I don't know if that's the best way to say it, but I guess it's one way to say it, okay? Which means that this approach is much more powerful, because if in the end, the best strategy is a strategy that involves entry, exit, stop loss, and take profit, the grammar is able to represent that. But if the best strategy is something that only has the entry and like just buy and holds after that given condition, we are also able to represent that, which means that we don't preemptively bias the grammar into like any given place in a search space, which in some cases might be exactly what you want to do. Like biasing on its own is not necessarily a bad thing. Like if you already know that the best strategies are those that have those components, and you are absolutely certain of that, it might make sense to bias the strategy to only look at the strategies. But the point here is that I'm not a finance guy. Like I'm not a pro quant or anything. I'm just an enthusiast learning about this field. And so it doesn't really make sense at my level with the level of, I guess, non-expertise I have, to force the search space to be in a certain region, to be constrained in a certain region, even though it would drastically reduce the search space and maybe make it so that it's easier to find solutions, when I have no reason yet to assume that this is the best place. So changing the grammar in such a way would have implied modifying the mapper to work with that. But since the mapper was tightly coupled with the other approach, and there was already so many other things to change, I figured it wasn't worth the hassle. Okay. The next issue, and that's a big one. That's a big one, and I think like that's where it's a skill issue on my part, due to my lack of ability with like agentic coding at the moment. As I said last time, I use RoboDev for that because of the free 20 million tokens. I know that like with Cloud Code and those other things, you have like cloud.md documents or like some document that you can define to enforce the architecture, to enforce the way the agent should look and work on your code to make sure that you have the best possible solution.
With Rival Dev, I haven't figured yet if there's a way to do that. And frankly, since it was like just a quick project in my mind, I didn't really bother looking too much into it. In hindsight, I definitely should have. But the point is that I didn't. And so whenever we were encountering issues, and by we here I mean me and the agent, I would often just default to asking the agent to like, okay, well, you got that. We defined the tests already to pass, but right now you're not passing them. So, well, yeah, correct yourself to work on that to get those tests to pass. Or like we need those features here, and so well, do that. Like implement the feature that I asked you to do. Maybe because I didn't have Cloud MD, maybe because I didn't have some other, I was missing something important to like get it to actually do what I wanted to do. In the end, the AI would often default to basically writing code that was, I really don't know how to call it. For the backtesting module, for example, and just evaluation, we had 3 evaluators independent in 3 different parts of the program that all claimed to do the same thing more or less. And the thing is, some of them were stubbed and so were actually useless. Others were not actually fully stubbed, but still were not really defined in a way that was meaningfully useful. Like, were just literally hard-coded with how they should do the evaluation. Or at times, literally giving random scores to solutions. That made it so like, okay, yeah, there's actually just no... Making it work would require me to figure out which of these evaluation is actually the best candidate to start with, and then wire everything else of this clusterfuck to connect to that, which yet again for a fully AI coded project wasn't worth the hassle. And so like the code was tangled as hell. It was hard to understand because a lot of the time it would have a function that claims to do something but then doesn't really do it, and then you have to like pause and think, okay, am I the dumb one for not seeing what it's actually trying to do, or is it just not doing what it's claiming to do? That kind of stuff. Okay, and so that is where the new bytecode approach shines, because with the bytecode and with the mapper working in that way, I'm able to directly everything is directly implemented as like a program, which means that at the end of the day, I can just run the program in my VM and then see the result of the execution of the program and then give a score to that. And in this case, we have a definite score function, which is just the calmer ratio, which I chose because it is much more representative of what you'd likely want a strategy to give you. Like a good ratio of like annualized returns and not too big of a drawdown. Like you'd want to like have those two balanced. And it's not as easily gameable as the sharp ratio, right? And like if you do game it, it's unlikely that you would actually be able to like game it consistently enough that you wouldn't be called off for being a fraud eventually. And so if you were hyped for this series, the new version that I'm working on right now, the bytecoding and all that, is in the works right now, and it's looking pretty dang good actually. This time I actually made sure that I understand everything that is happening. And so I will try recording that and showing that in the future. Potentially, I don't know yet when, but soon enough. But yeah, if you'd like to know more about what's happening, stay tuned. And if not, that's good as well. Have a really nice evening, really nice day, Johnny.